Lesson 2:2, solving one-step equations. Our essential question is, how do you solve a one-step equation? We have one new vocabulary word today. It's inverse operations. Inverse operations are operations that reverse each other. So the inverse operations that we're going to focus on first would be adding and subtracting, and multiplying and dividing. We have three addition equations on this first slide. The first one, x plus 7 equals 10. The second one, 2/3 equals x plus 3/8. And then the last one, x minus -11 equals -5. So to solve all of these equations, I'm going to show you the method that I prefer to use. I prefer to separate with my equal sign, what I call like a train track. I just do a single track through that equal sign so that I can clearly see the two different sides of my equation. Because when you're solving equations, the equal sign is like representing a balance, like a balanced scale. And what you see on one side of the equation has to have the same value as what you see on the other side. So we're trying to figure out what x is equal to. Some of these equations you might be able to look at and solve in your head, like this first one. You might look at it and say, well, I know what would equal 10. It's 3 plus 7. And that's great. If you can do that, that's great. What I want you to do, if you can solve it in your head though, is I want you to show me by plugging it in. So if you look at that first one and you say, you know what, I don't need to solve it, writing out a bunch of steps, I know it's 3, that's great. You can write on your paper x equals 3, but then I want you to show that it works like this. I want you to prove to me that if you put the 3 where the x is, 3 plus 7 is 10, so it does work. So if you solve it in your head, you need to prove it to me that it works so that you don't make a mistake. Because a lot of times on problems like these, we see mistakes made just because people aren't careful. Like they hurry through. So here's the method that you're going to see me using. I've got my train track. I look for the variable. My variable is x. If 7 is being added to x, I know that the inverse of adding 7 is subtracting 7. If I subtract 7 on each side of my equation, that's okay, because it's like taking 7 off of each side of a balanced scale. It's not going to affect that equality. So as long as you do the same thing on each side, the equality, the equal sign, stays intact. So now x equals 10 minus 7, which is 3. When you get to work with more difficult equations, more difficult numbers, it is really important to have a method. And not just looking at it and thinking you can always solve something in your head. Okay, now I'm skipping to the third one here in my list. When you subtract a -11, we learned that taking away the negative actually turns it into a plus. I like to say it's a chunky plus, a double negative. So x plus 11 means that to solve this, my variable has 11 being added, so the inverse is to subtract 11, so I subtract 11 on both sides. Now, -5 minus 11 more is the same as -5 plus -11, so x equals -16. If you're not very good at working with integers, you may have a little bit of an issue with some of these problems. So writing side by side, -5 minus 11, might be easier for you than seeing it up and down. It doesn't matter at all how you show your work. Okay, now the third example, clearly more difficult because we've got fractions involved. So my variable has 3/8 being added to it, so I need to subtract 3/8 on both sides. Now, when I subtract 3/8, this becomes a more complicated problem because 2/3 minus 3/8, in order to subtract fractions, we have to have common denominators. So the common denominator to use for the 3 and the 8 would be 24. So I need to change both fractions here to get 24 in my denominator. Okay, so I am going to need to multiply my first fraction by 8 in the numerator and denominator. 8 times 2 is 16. My second one I have to multiply by 3. 3 times 3 is 9. So now, 16 minus 9 is 7. My final answer is 7/24. Common denominators are required whenever you're adding or subtracting fractions. Okay, now we have 3 subtraction equations. And the inverse of subtracting is adding. And we're going to be careful, again, with our integer operations. So my first one, pretty basic. The inverse of subtracting 9 from my variable is adding 9. So I add 9 on both sides. 4 plus 9 is 13. Second one, the inverse of subtracting 3, adding 3. -8 plus 3 is -5. Remember, when they have opposite signs, you're actually subtracting the numbers 8 and 3 to get 5. You're taking the sign from the one that you have more of. Now the trickier one, I'm subtracting 1/5. The inverse of that is adding 1/5. So I'm going to write this one as -3/10 plus 1/5. And the common denominator on this one, our common denominator is 10. So I'm only going to have to rewrite one of my fractions. So 5 times 2 is 10. 1 times 2 is 2. -3 plus 2 is -1. So -1/10 equals x. Next up, we have multiplication equations. The first one, -25 equals -5x. Second one, 4x equals -28. The inverse of multiplying is dividing. The only thing to remember on these that's a little tricky is that you're going to divide by exactly what coefficient number is in front of x. So if it's a -5, then you're dividing by -5. If it's a 4, you're dividing by 4. So just be careful and make sure that whatever sign is on that coefficient comes with it when you divide. Now, dividing a negative divided by a negative is a positive, so 5 equals x, and x equals -7. A negative divided by a positive is a negative. So 2 negatives, and it's a positive. 1 negative when you're dividing, and it stays a negative. Next up, division equations. On the division equations, so both of these have a variable on the top of the fraction. So my first one, x has been divided by -3. The inverse of dividing by -3 is to multiply by -3. So if I multiply both sides by -3, I will get x equals positive 18. Negative times a negative is a positive. The next one, I'll show my work just a little different. multiply by -5 on both sides, like this, and x equals 10 times -5, or -50. The ones that look like fractions are the ones that students typically forget how to solve. So when it looks like a fraction, that means something is being divided. So when it looks like a fraction, something's being divided, you have to multiply. All right, now, solving fraction equations. Fraction equations like these are a little bit trickier. You can solve them as two steps that are separate from each other or as one step. And I'm going to show you how to do the one-step method and the two-step method both, because you can really choose whichever method you prefer. So to solve these problems as two separate steps, if you look at where the variable is being multiplied by 2 and then divided by 3. So what I could do is I could multiply by the 3 that you see on the bottom of the fraction first, and that will cancel out the 3. That will leave me with 2x equals -6 times 3, which is -18. Then the second step would involve dividing by the 2 that's in front of the x, like this, and then my final answer would be -9. Now, if you would prefer doing that in one step, what we do is we multiply by the reciprocal. So we take that fraction, which on my new problem is -3/4, and we multiply by its reciprocal, which means to take the fraction and flip it over. Doing this gets rid of the entire fraction in one step instead of two. So, my 4's would cross cancel, and so would my -3's. I'm going to put a 1 underneath my -2 on the other side, so that when I multiply these, I can multiply straight across. -2 times 4 is -8, 1 times -3 is -3, and a negative divided by a negative is a positive. So I can leave this as 8/3, or I could make it a mixed number, 2 and 2/3, because 3 goes into 8 twice, which is 6, and leaves 2. So 2 and 2/3. So either of these methods is okay. You can solve these fraction problems when there's a fraction multiplied by your variable. You can solve it with two separate steps, multiplying and then dividing, or one step where you multiply by the reciprocal. You should be able to write a summary now explaining how to solve a one-step equation. So that means all of the ones that we've talked about, how to solve any of those equations.